What's up guys, long time no see. So this is what we're going to create in this tutorial. I have built some custom nodes for this project. So download the asset file, link in the description. You can even download this project file, but the link is somewhere in the video. You have to find it. Okay, so what I'll do is we'll go to the geometry nodes layout and create a new node tree, and I will delete this group input node because we don't need it. And if you have downloaded the asset file and put it in your library, you should be able to see this menu in your add menu. Here we have some nodes which will help you to get certain things done in this project. Or you can go into file and append the node trees from the asset file. Okay, so first of all, I'm going to create a mesh primitive cylinder, and we'll change this cylinder into a triangle. So to do that, I will change the vertices to 3 and depth to a very small number, something like this 0.02. Okay, so right now the pivot point of this triangle is in the center. So if I try to rotate this triangle, it will rotate around the center. So what I want is I want the pivot point to be at the edge of this triangle. So what I'll do is we can shift this triangle into x-axis 0.5 unit, and if I try to rotate in y-axis, you can see it's rotating around the edge. That's what we want. Okay, so I'm going to delete that, and okay, now we're going to duplicate this triangle into a honeycomb pattern, and to do that I will use a TP honeycomb points from the TP asset menu, and we can use a instance on points node. So connect the points to points and the cylinder to in our case it's a triangle, so to instance, and then if we see that, you can see we have a honeycomb pattern. Okay, so right now I just want to focus on the single instance of the triangle accordion. So what I'll do is I will change the XY count to 1. This is basically generating a single point in 3D space, and instance on points is placing this triangle right there, right at the point which is being generated by the honeycomb pattern. Okay, so what I want is I want not just one triangle but multiple triangles, at least 3 triangles, but I will duplicate this point to maybe 6 or 7 times. So we can use a duplicate elements node for this, duplicate elements, and I will duplicate this to, let's say, 7 times. So we have 7 triangles at the same position in 3D space. Now we can change their rotation to offset in, let's say, y-axis. So how can we do that with a certain fixed number? So how can we do that? We can use the step effector from the TP asset menu. So let's go and create the TP assets, TP step effector. TP step effector. So connect the points to points and duplicate index to attribute. So this TP step effector needs certain attribute which it can uses to distribute the values between the fields. So it could be index, it could be distance, it could be volume, whatever. So now we will change the rotation of these triangles in y-axis. So I need to access the y channel, which we can do that by using a combine XYZ node and connect the y. So you can see our triangle has rotated, and if we change the offset, let's turn off the normalized offset right now. So you can see it's how it's working, but I will change the in value to negative 180 degrees. So to do that, I can use the negative pi. So negative pi. So now if I change the offset, you can see how it's working. Okay, let's change the look of these triangles. So we go to the render settings, and first I will change the viewport shading to this, which is called viewport shading, and I will turn on the ambient occlusion, and will increase the instant distance and turn off the bounce approximation. So now we will apply some materials on this triangle. So right now we have 2 materials in the scene, white and let's rename this to red, and I will change the color to red as well. So hue is 0, which means it's red, and I will just increase the saturation and value, something like this. And to apply this material on these triangles, I can use a set material node. So create set material and change this to red. So I don't want all the triangles to be red. I just want first 2 triangles to be red, and remaining should be white. So I'll duplicate this node and change this to white. And for the selection, for the red material, I can use a TP range node from the TP asset menu, and we need a index. So for that, I will use the duplicate index, and we'll use this as a selection. And before any of these nodes to work, we have to realize our instances. So I'm going to create the realize instance node here, and you can see our first 2 triangles are red. We can change the number of red triangles by just increasing the index, but in this case I just want at least 2 triangles to be red, so we'll change this to 1, 0 to 1. So we have basically 2 triangles. Okay, now let's take a look. So we'll change our offset, and this is how it's looking. Now I want to animate these triangles, so we can either keyframe this offset, or we can use other methods. So I'm going to first of all split this spreadsheet and open our timeline editor, change the time range to 0 to, let's say, 100 for now. And what we'll do is we'll create a map range. So if I turn on the normalize offset, it will only accept the values between 0 to 1, and then we can use a map range node, right? So I will connect this to offset, and to import the time, I can use scene input, scene time, SCE, scene time, and we'll connect we'll use the frames and connect to the value. And now I want this animation to be from 0 to, let's say, 50 frames. So I'll set this to 0 to 50 frames. So now we have an animation which is coming from timeline without setting any keyframes. All right, now we have to fix a very severe problem, because all the triangles on the same position in 3D space, they are all intersecting with each other. Okay, so you can see all the triangles. So if I change the viewport shading to wireframe, you can see clearly that all the triangles are on the same position. So to fix this problem, if we offset each triangle in z-axis just a tiny bit, it should solve the problem. And to do that, we can use another step effector in z-axis. So we have to change the position of these points or instance. So we can use the set position node here, set position, and I will insert it after. You can insert it before instance on points, and I'm going to move it here. And first we will use the combine xyz node to separate these channels, and we'll use the z-axis. So let's create the TP step effector, and we have to connect our inputs. So geometry as points, and duplicate index as attribute. Okay, and now I can connect this to z, and you'll see our triangles has disappeared. But if we change the offset value, you can see, let me change the viewport shading back to normal. Let's change the in value to something small like 0.01, and let's see. Okay, this seems right. So let's change this to wireframe shading, and if I change the offset to 0.5, you will see it's distributing all the triangles a fixed value in z position. So that's what we want. So this is this should solve our problem, the intersection problem. But you will see it's not, it's still intersecting. And the reason is, you can think of these triangles, or the accordion, this triangle accordion, as a book. And in a book we have two things: we have book covers and we have pages. So when we flip the pages, the position of each page shifts in the axis. So we can do the same thing here. So I will not animate the offset because it's going to be fixed. What we will animate is the end value. So let's say if it's on one side, the end value should be 0.01, and on the other side it should be negative 0.10. Okay, so to animate that, we can use another map range, and normalized offset is turned on, which will basically force this to use only values between 0 to 1. So we'll connect this to end value, and before that I'm going to copy the end value and we'll paste it here, and we'll change this to negative, from positive to negative. And we can connect the same map range which is feeding values to the rotation offset. So because it's outputting value between 0 to 1, so let's connect this to our value, and it should solve our problem. Let's see. Now still intersecting. So what I'll do is I will flip these values. So I'm going to make this one negative 0.01, and I will make this positive. So that has solved. I think this is correct. All right, so okay, so now we have to solve another problem. As I said, think of this triangle accordion as a book. So in book we have two things: covers and pages, and we have to find a way to not animate the covers but the pages only. And to do that, we can restrict certain indexes from getting the rotation value. So let me show you the index number associated with each triangle. So this is 0, this is 1, this is 2, this is 3, this is 4, 5, and 6. And I don't want this 0 and 6 and 0 to be animated, and I want only the animation between 1 to 5. So how can we do that? If we go here, which is our rotation, we're going to make some decisions here. So we can use a switch and compare node to basically choose between the indexes. To make this process easier, I'm going to create the index range node here, and I will connect this duplicate index to index, and then we can choose easily the index range. So I want one start index to be 1 and end index to be 5, and then we can use a switch node. So create a switch node, change this to float, and now the true socket will use this. So all the rotation will go to the index 1 to 5, right? And let's move it a little bit. All right, so if we scrub our timeline, you can see how it's looking. So all the rotating triangles are between index 1 to 5, and this two static triangle is basically 0 and 6. Okay, but I want these triangles to be controlled separately. How can we separate these two triangles? So we can use another compare and switch. So we'll create a compare node, set this to equal, and we'll select the 6th index. Let's create a switch node, and we'll change this to float, and we'll use this as a selection. So now connect this to the false. Now the true will control the 6th index, which is this one, and false will control this one, which is the index 0. So I don't want any rotation value uh, any sort of animation in this, so I will just keep it as it is, and I will change the true, which is the sixth index, to be flipped. So we can flip it 180 degrees. So I'll use negative pi for this, negative pi, and this should solve our problem. Yes, you can see. So one side is red, another side is white, and we have some flipping pages in between. All right, so now let's just organize it a little bit. So okay, so now we have this, and now what we'll do is we'll increase the number of instances and arrange in, you know, honeycomb pattern. So basically, let's say I'm going to change this to 10. So we have 10 triangles, and now we will decrease the gap between these triangles. So I will go to the top and change the people shading to wireframe, and let's decrease the scale first. So, and then offset. All right, if I zoom out, and if I scrub the timeline, you can see all the triangles are animating at the same time, which we don't want. We want them to be animate, like, let's say sequentially or randomly. So how can we do that? I'm going to animate them sequentially, and to do that, so if we add the index value here, it should offset the rotation value of, or the all the animation values of these instances. So to do that, let's create a add, and we'll add the index number here. So create the index. Now don't be confused with the duplicate index. It's index and it's per triangle. So I'm going to connect this to the value, and you'll see if I change the timeline, it's working, but we have to adjust our values here. So, to min to max, but I don't want to do that. Because why? Because this is feeding a normalized value, which is giving only 0 to 1 values to all the to the rotation and the position z offset. So I don't want to disturb that. So what I'll do is I will add a map range just before the scene time. So let's create the map range, but they need to be connected somehow, because the minimum and maximum has to be the same. So one node will control the start frame and the in frame start value and the in value, and the second map range is basically compressing all the values between 0 to 1. We can create a common input for that. So create a value node, value, and shift D, connect this here and to this as well. So our end value in frame is going to be, let's say 50, or let's say 100, and then we can change this value. So if we are on the 0 frame, we can change the minimum like 600 or something, and then we go to the frame 100 and change the max to something like this. Okay, now we have this some depth issues here, but it should not be visible in the cycles. We are having problem because we are using the EV render engine. Let's change this to cycles and GPU compute, and now if I animate, you can see it's working and it's very fast. So I will increase the in frame to 150 frames, and then we have to adjust this number, set this to 150. So it's all good, it's all fine. Our main job is done here, but we want, let's say we want to add some randomness here. So how can we do that? Well, we can add some randomness to the index, mix some randomness with the index. So let's try to do that. It's not gonna work, but let's try to do that. So I'm gonna use a mix node here, mix, and we'll use a random value, and connect this to here, and let's randomize it. So if we look it from the top, and let's go in the middle, and now we can use the minimum and maximum. You can see that the it's not randomizing the instances, but it's randomizing each triangle's rotation, which is not what we want. You can see the distance between each triangle has changed weirdly because each triangle is receiving a different random value, and that is the problem. So to fix that, what I'll do is I will not connect this random value here, but before duplicating all these triangles, so before the duplicate elements, and to add this random value, we can use a custom attribute. So we can create a custom attribute, stored named attribute, and it's going to be a float stored on point, and I'm gonna call it rand. You can call it whatever you want, and let's connect this random value here. Okay, and now if we access that custom attribute with a named attribute node, select the rand, and now if I connect this here, it will randomize the instances. You can see our rotation has each rotation offset has fixed between the triangles. So if we go to the top, and now where is that random node here, I'm going to change this to 0, so it's 0. And now if I change this number, you can see it's randomizing the instances, and that's what we want. And I think this is what we are looking for. This is the final result. I think that's it for this tutorial. I am still learning the geometry nodes, so if you have any feedback or suggestions, feel free to go into the comment section and give me your valuable feedback. It would be really awesome. So thank you so much for watching this tutorial. I'll see you next time. Happy blending.